Today's lesson is hyperbolas, and we are going to be doing the graphing today. Okay, my learning objective is I can graph hyperbolas from standard form or general form. Let's start out with the definition. A hyperbola is a set of points such that the difference of the distances from any point on the hyperbola to two fixed points remains constant. So I'm talking about from the focus to the hyperbola to the other focus. So these fixed points are called foci, which is plural for focus of the hyperbola, and the distance. So distance is absolute value. So we're saying d2 minus d1. I'm taking the absolute value because distance is positive. And what we'll find out is that is equal to 2 times a. Okay, so we're going to get to that later. So, and distance is absolute value. So it really doesn't matter if I take d1 minus d2 or d2 minus d1 if I take the absolute value. All right, so how do I know from a general equation of conics when I have a hyperbola? I am looking at A and C. And what I find is they have opposite signs. So one is negative and one is positive, okay? So I have one positive and one negative. Okay, so A is always under the positive term. A does not have to be larger than B. So the positive squared term indicates the direction of the major axis, which is called the transverse axis, and the minor axis is called the conjugate axis. Okay, so we can have a horizontal or a vertical hyperbola. So the center is at the midpoint of the foci. Okay, the asymptotes are the diagonals that guide the curves. The vertices are plus or minus a units from the center. So here are my vertices. So A is from the center to the vertex. The co-vertices are plus or minus B units. Here we go. Plus or minus B units from the center. So here are my co-vertices. So this is my B distance, and the foci are plus or minus C units away from the center. So here is from here to here is C. Oops, C. From here to here is C. So again, I can move C from A to B. So I can move that here. So this time C is the longest side. So this one is using kind of the standard Pythagorean theorem. So C is the longest, not A, like in the ellipse. So C squared is going to be a squared plus b squared. Oops. Let's try that again. So c squared is going to be equal to a squared plus b squared, because c on a hyperbola is the longest side. So this is the standard Pythagorean theorem, but c happens to be the hypotenuse. Okay, so let's do the same thing on the vertical. So a is to the vertices. So a is from the center to the vertices. So here's a. B is to the co-vertices. So from here to here is B. And C is to the foci. So here is C. Okay. So I can redraw C and make my triangle here. Okay, so let's talk about standard form. So standard form, I put the plus term first. So A is whatever is under the plus term. So this is my plus term. So whatever the positive term, A is under the plus term. So for a horizontal hyperbola, the plus term is the x term. So this is a horizontal hyperbola. And the plus term is under the y term for a vertical hyperbola. Okay, so to find the asymptotes. So the asymptotes, let's see. So the asymptotes here are these lines that guide the curves. Okay. And we are going to use slope. So slope is rise over run. So we're going to make these boxes and we're going to use rise over run. So whatever is the rise. So for the horizontal hyperbola, rise is B and run is A. But for the vertical, rise is A and run is B. So they're backwards or reciprocals of each other. Okay, so I am using like point slope form because I am finding the equation of those lines. So point slope form is y minus y1 equals slope times x minus x1. And x and y is the center of my circle. Or center of my circle. Center of my hyperbola. So what I'm going to find is, to find my equation of my line, I am going to add k to both sides to bring that over here. So the equation of my line is going to be y equals plus or minus b divided by a over times x minus 1. So these are reciprocals depending on if I have a horizontal or a vertical hyperbola. So this is plus k over here to find the equation of my asymptotes. Okay, so how am I graphing this? So I'm going to write the equation in standard form first. I'm going to first graph the center. I'm going to graph the vertices. The vertices I'm going to know are a distance away A. Then I'm going to graph the co-vertices, which is B. And then I'm going to draw a rectangle with the, and I didn't finish here, A and B sides. And I'm going to use the formula c squared equals a squared plus b squared to find and graph the foci. And then I'm going to write the equation of the asymptotes and graph them. All right. Let's look at the first one here. Okay, so number one, I'm already in standard form. So I know what my center is. I can say my H and K. So my center is at 3, 2. So I'm going to graph 3, 2. So 3, 2. Here's my center. So my plus term is the x term. So I know I have a horizontal hyperbola. So I'm just kind of giving myself a clue. So I know what I'm graphing. Okay, so the next step says graph the vertices. So I know a squared is 25. So I know a is 5. So I am going to graph 5 to the right and 5 to the left. So 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. So my vertices are at -2, 2 and at 8, 2. Okay. So I know b squared is 16, so I know b is 4. So from the vertex here, I am going to go up 4. 1, 2, 3, 4. And 1, 2, 3, 4. Okay, and then I'm going to make a box from these. Okay, so here's my box. I'm going to draw my box in. Okay. And then my asymptotes are going to go through the corners of the boxes and the center. Okay, so I'm going to draw in my asymptotes. There we go. So then I can draw in my hyperbola. Oh, I need to do my foci next. So the foci, I'm going to plot those in first. So c squared is the foci, is a squared plus b squared. So c squared is 25 plus 16. So c squared is 41. So c is the square root of 41, which is approximately 6.4. So I'm going to go 6.4 from the center, right and left. So 1, 2, 3, 4, 5, 6.4, and 5, 6.4. So here's my foci. Okay, and then I'm going to just sketch in and follow to the asymptotes, but I'm not going to go across them. Okay, there we go. So here's my sketch. And what are the equations? What are the, so the foci are at, so the foci are at, I'm going 3 and plus or minus the square root of 41. 3 plus or minus the square root of 41, and then up 2. And then I want the equation of the asymptotes. So we said A is 5. So on here, A is 5. So from here to here is 5. And b is 4. So rise over run. So we're going to substitute in. So my asymptotes are going to be, here, we'll make this so we can see this. So then my asymptotes setting into my equation. So I'm substituting in y equals rise over run. So rise is 4. So I'm going to do the positive one first. Positive 4, rise over run, 4 over 5. And then x minus h is 3 plus k is 2. So here's h and here is k. Okay, I'm going to distribute first. So this is going to be y equals 4/5 x. So 4 times negative 3 is negative 12 over 5. And 2, so plus 2. So I'm going to change this to fifths. So I'm going to multiply by 1 in the form of 5 over 5. So this is 10 here. So I have, I guess I wrote minus up here. It's really just minus here. There we go. So minus, there we go. So now I'm going to simplify. So I have y equals 4/5 x, and I have minus 12 and plus 10, so I have minus 2/5. So here is the positive slope asymptote. And then I'm going to do the negative slope asymptote. So that's going to be y equals negative 4/5 x minus 3 plus 2. So this is going to be y equals negative 4/5 x plus 12 over 5 plus 2. And again, I'm going to multiply by 1 in the form of 5 over 5. So simplifying, I get y equals minus 4/5 x. And I have positive 12 plus 10, so plus 22 over 5. So these are my two asymptotes. So this is my positive asymptote. This is my negative asymptote. Okay, there's just a lot of steps, but I don't think it's hard. And I like this one because then it's got the Pythagorean theorem in the standard form. Okay, I have one more example. So this time I'm going to not start in standard form. So I have the general form, and I'll need to complete the square first and then do the whole process. So I'm going to start with completing the square. So I'm going to put the x terms together, the y terms together, and then the constant on the other side of the equation. So I'm going to start out with, I have minus 4x squared. It's going to be easier to see it. There we go. Minus 4x squared plus 40x. And then I'm going to add something. Plus y squared plus 12y plus something, and that's going to equal 80 plus the two things I'm adding. Okay, first I want to factor out a negative 4 from the x terms because I want a 1 in front of my squared terms. So I'm going to factor out a negative 4. So I have x squared minus 10x plus something plus y squared plus 12y plus something equals 80 plus the two things I'm adding. Okay, so I got minus 4. So half of 10 is 5. So 5 squared is 25, but I'm multiplying this times negative 4. So that would be minus 100 that I'm adding, plus y, half of 12 is 6. 6 squared is 36, so I'm going to add 36. And 80 minus 100 plus 36 equals 1. Or 16, I'm sorry, equals 16. So the next step, I need to set it equal to 1. So I am going to divide both sides by 16. So I'm going to divide each term by 16. Okay, so the next thing I see is the x term is negative. So I'm going to move that as the second term, and I'm going to bring the positive term first, the y term. So this is going to be y plus 6 quantity squared divided by 16 minus, and 16 divided by 4 is 4. So that'll be x minus 5 quantity squared divided by 4 equals 1. So since my plus term is the y term, I know I have a vertical hyperbola. So I know that a squared is 16, so a equals 4, and b squared equals 4, so b equals 2 for graphing purposes. So I'm going to start out with my center is at h is 5 and k is negative 6. So my center is at 5, negative 6. So I'm going to graph that first. So 5, negative 6. So I know I'm going to be vertical. So I'm going to graph this way. So my vertices, so my A value, we said is 4. So I'm going to go up 4, 1, 2, 3, 4. And down 4, 1, 2, 3, 4. It's my A value. And then I said B is 2. So I'm going to go right and left 2 from my center. Oops. So I'm going to make my box from my A and B values, my rectangle. Okay, and then I'm going to draw my asymptotes through the center and the corners of the rectangle. These are going to be the guiding lines for my hyperbola. So my vertices, we said, are at 5, negative 2, and 5, negative 10. Next, I have to find my foci. So I know c squared is a squared plus b squared. So c squared is we said a squared is 16 and b squared is 4. So 16 plus 4. So c squared is 20. So c is the square root of 20, which is 4 times 5. So c is 2 times the square root of 5, which is approximately 4.5. So that's on the major axis. So here's 1, 2, 3, 4.5, and 4.5. So my foci are at 5, and then -6, and then I'm adding and subtracting 2 times the square root of 5. Right, so last thing I need to do is find the equations of my asymptotes. So my asymptotes, so my rise. So I'm just looking at, just one square here. So my rise is 4 and my run is 2. So I know I'm doing 4 over 2, which is 2. So let's do, so I have y equals, for my positive asymptote, 4 over 2, which is 2. So x minus 5, x minus h, plus k, which is -6. So distributing, I get y equals 2x minus 10 minus 6. So I get y equals 2x minus 16. So here's one equation. And for my negative asymptote, I get y equals, I have a -2 for a slope, x minus 5 minus 6. So y equals -2x plus 10 minus 6. So y equals -2x plus 4. Okay, we are done.